Hello everyone, here are the solutions to 1 through 4 off of worksheet 6.2 from yesterday. I'm going to go over number 1, and then if you have questions on any of the others, just let me know. So for number 1, we want to turn the data value of 350 into a z-score. So what we would do is say that z is equal to, we're looking to see the probability that a randomly selected admission charge is less than $3.50. So that is our data value, 350. We're going to subtract 581 from this. That is our population mean. And divide by the standard deviation, which is 0.81. So this should give us a z value of negative 2.85. So then we write our probability out. So the probability that z is less than negative 2.85. This is going to be a very small shaded region here because we're to the left of negative 2.85. So this should be about 0.0022. So notice it's about 0.22% that the probability of the selected admission charge would be less than 350. So that's, again, what we're doing for each problem here. So take a look at the others. Like I said, email me if you have questions on any of these. All right, the second part of section 6.2, we're still working with applications of the normal distribution. However, we are going to kind of have to rearrange, find the other missing parts of the formula to find the z value. So here we're going to find data values given specific probabilities. So if we're asked to find the data value, what we're going to do is we're going to take the z value formula, and we could just rearrange this to solve for different missing parts. So if we wanted to find x, all we'd have to do is solve this for x. So that means I'm going to multiply both sides by the standard deviation. So z times the standard deviation is going to be x minus mu. Solve for x, just flip this around. So x is going to equal z times our standard deviation plus mu. Let's now solve for the standard deviation. So again, I would multiply both sides by it, and then just divide by z. So if the standard deviation is ever missing, all we do is still x minus mu, but we divide by z. And then let's say we wanted to solve for mu. Again, I would multiply both sides by the standard deviation. Then I could add mu, and then subtract z times the standard deviation. So mu is just going to equal x minus z times our standard deviation. All right, so we have 4 versions of the formula. We use this when we're trying to find the z value. We use this version if we're trying to find the data value, this version if we're trying to find standard deviation, and then this version if we're trying to find the population mean. Let's take a look at our first example. Go ahead and pause the video to copy this down. So it says, in a normal distribution, we want to find the standard deviation when the mean is 26 and 7% of the area lies to the left of 14. Sometimes making a sketch is going to be helpful for when it comes time to figure out what's given and what's missing, and what kind of z value we can expect to get here. So right now, we don't have anything turned into a z value. So notice how I'm going to write this. This is not the standard normal distribution. This is just a normal distribution. So my mean is going to be 26. And then I have this data value of 14. So I know that's to the left of the mean. So I'm going to put 14 right over here. And then I know that this area right here is 7%. So now I could turn this 14 by using the calculator. I could turn the 14 into a z value. So in this case, first, we want to find z using the calculator and the area. So go ahead and do that. And we should be getting z is equal to a negative 1.48, which makes sense. So now we have mu, we have our x. So again, x is 14. We have z. Mu is 26. We can use the formula. Now you don't have to start with the rearrangement. You can always just substitute it into the formula for z and then rearrange it afterwards. So now if we go back, we know that our standard deviation is equal to x minus mu over z. So this just becomes 14 minus 26 over a negative 1.48. In this case, we're going to round to just one more decimal place than the raw data that's right here. So we should be getting an 8.1. So our standard deviation is 8.1. Okay, let's take a look at example 2. Pause the video to copy this down. In a normal distribution, find the mean when the standard deviation is 20 and 10.26% lies to the right of 100. So again, in this case, I'm just creating a normal distribution where 100 is right in the middle here. Actually, no, our mu is, rather. Now, since 10.26% lies to the right of 100, I know that 100 has to be greater than our mean because 10.2% or 0.26% is definitely not the entire 50%. So I know it can't be to the left of mu. So right here, this is going to be our data value of 100. So x is equal to 100. Mu is missing. Sigma is 20. So we want to find what z value 100 turns into. So we're still going to find z. But remember, our calculator takes the area to the left. So if this is 10.26%, we need to find what percent this area is. And all we have to do is subtract 10.26 from 100, right? So go ahead and do that. Then we should be getting 89.74%. So this is the area we're going to type into the calculator. We should be getting 1.27 for z. So this translates into 1.27 on a standard normal distribution. So now to find mu, if we go back to that version, we know that mu is equal to x minus z times our standard deviation. So this is going to be 100 minus 1.27 times 20. And we should be getting a 74.6. All right, just two more examples to go through. Go ahead, pause the video and read over number 3. All right, so let's take a look at this one. again, I'm just drawing a normal distribution. Here we have the mean of 200, so right here in the middle, that's our population mean of 200 and a standard deviation of 20. We're asked to find the lowest possible score to qualify. Assume the test scores are normally distributed. So they must score in the top 10%. So right here, we've got our top 10%. So we're looking for this cutoff score, which is X. But remember, area is going to give us the Z value first. So once we have Z, so again, we need to find Z using the area. So kind of like the last problem, I need to type in the area to the left of this data value, which this is a lot easier of a calculation. If 10% is above it, 90% is below. So go ahead and type that in. And here we should be getting a 1.28 for Z. So we need to find X. So if you recall, the formula for X is going to be Z times our standard deviation plus mu. So we get 1.28 times 20 plus 200. So this should give us 225.6. So we're going to answer the question. So, and this could vary. You could use this exactly, or this is if you're giving this sort of a test to have someone qualify for the police academy, you can cut it off a little bit above or a little bit below, as long as we're close enough to this. So we can maybe say a score of 226 could be used as a cutoff. Or you could say anyone scoring 226 or higher qualifies. All right, let's try one more. Again, pause this to read it over, copy it down. So this is very similar to our last example. The question being, find the upper and lower readings that would qualify people to participate in the study. So we're after the X values. So if we make a sketch again, notice it says the middle 60%. So the mean systolic blood pressure is 120. So we've got 120 right in the middle. So the middle 60% means we have 30% here and 30% over here. So we're trying to find these X values, which first we have to find the Z scores associated with them. And to help us on the calculator, we want to type in the area that's to the left of this value that's right here. And that would be what percent? Should be 20 because the lower half is 50. So we're going to type in 0.2 there to find the first Z value. I'll call that Z sub 1. All right, so that's going to equal a negative 0.84. And then we know Z sub 2 is metric, so that's going to equal positive 0.84. So over here, this would give us our lower limit. So we want to find the X value. So again, we're going to say X sub 1 is going to equal, remember it was Z times our standard deviation is 8. So we're going to have negative 0.84 times 8 plus our 120. And then our upper limit over here, X sub 2 is going to equal positive 0.84 times 8 plus 120. So our lower limit is turning out to be 113.28, and our upper limit is 126.72. So we would say the middle 60% will have blood pressure readings between, or the people that can participate in the study would have to have blood pressure readings between these two values. And again, you could use these decimals, or you could say 113 to 127 if you wanted to. All right, but just some more examples dealing with the standard normal distribution. So off of worksheet 6.2 now, you can continue working on 5 through 10, 12 through 15. So next week, we're going to wrap up section 6.2, start 6.3. I'm going to give you guys another applying the concept. So it's looking like a quiz will say next Thursday over section 6.1 and 6.2. Let me know if you guys have any questions.